In this video, I will explain how to use time in DCR graphs in order to set deadlines and delay for activities. DCR graphs support two concepts for time: deadlines and delays. A deadline is used to ensure an activity is completed within a given time frame, for example 2 days, as can be seen here. A delay is used to postpone execution of an activity at least a given period of time, in this example here, 1 day. Let's look at an example. We have a graph with 3 activities: start, delay and deadline. There is a deadline of 2 days between start and deadline, which we can see by clicking the response relation and notice the number 2 in the deadline field here. We also see the 2 below the arrow. There is a delay of 1 day between start and delay. Again, we can click here and see the delay 1, which means the execution of delay have to be postponed for at least 1 day. In order to demonstrate this, let's try to simulate. We click simulate in the top and start simulation. We click render to see the graph to make it easier. We notice the time is now June 9th, 1:56 p.m. in the afternoon. We also notice we cannot execute the delay activity. It's gray, but the deadline and the start can be executed. When we execute the start activity, we notice that we cannot execute the delay activity, even though the start activity has been executed. The reason, of course, is the delay. We notice that there's a next delay tomorrow, the June 10th, and there's a deadline in 2 days, June 11th. We can advance time to the next delay, which we will do. And when we do that, the delay activity is enabled. We execute the delay, then we can advance. Then there's no more delay, as you can see here, but there's still a deadline. We can now advance time 3 days. When we do that, we get a warning that a deadline will be missed. We click OK and see that the time is now June 13. And as the time is June 13, the deadline is in the past, so it's marked as red. So, how do we handle the situation that we do not wish a deadline is passed? Obviously, we cannot stop time. But instead, we can start another activity that will handle the fact that a deadline has been passed. Before we proceed, I need to explain how aggressive and lazy user work. The aggressive user executes activities whenever it is enabled, and it re-executes them whenever it becomes pending. A lazy user executes an activity whenever it is pending and enabled, and it is re-executes whenever it becomes pending again. We say that the aggressive user is a little unintelligent, whereas the lazy user is pretty smart. So let's try to execute with the users here. So we choose the aggressive user to play the user role and see what happens. What we see is that the aggressive user first executes the deadline, then the start, and then the deadline again. The reason was that the start made the deadline. When we advance time, we see that the aggressive user immediately executes the delay activity. Instead, let's now try to simulate again, but this time with the lazy user. We try again here. So this time, nothing happens when we start the graph. We can click the start activity. When we do that, we notice that the deadline becomes pending. And as it's pending, it is immediately executed by the lazy user. If we advance the time 1 day, we can see that the delay is now enabled. It's not executed by the lazy user as it's not pending. Now let's look at a typical pattern for exception handling so we can handle deadlines properly before they're reached. In the top, we have 2 activities: start and important work. The important work cannot be done before start, and it must be done no later than 7 days after we start. Below, we have the exception handling activity, which has a delay and deadline of 7 days, indicated by these numbers. This means that whenever the deadline is reached, the delay is also reached, thereby enabling exception handling. If we assign exception handling to the lazy user acting as a robot, the robot will execute the exception handling event whenever it becomes enabled. Let's try to simulate. Again, we assign lazy user to the robot and click simulate. We click render to see the graph. We start the event. Let's say that a day then passes, and then the user does the important work. When that is done, we notice that the robot exception handling is excluded as the work was done in proper time. Let's try to simulate again. This time, reach the deadline. Again, we set the lazy user to be the robot. We render the graph to see it. We click start event. We notice that exception handling important work is done. So now we advance time to the next deadline. When we do that, we notice that the robot executes the exception handling process, thereby enabling them to do something else. So this is the typical pattern for exception handling. This ends our introduction to time DCR graphs, where we also had time to introduce the aggressive and lazy user. Learn more about time DCR graphs by using the links found here. Thank you for listening.